Covalent compounds. Covalent bonds and covalent compounds is the focus on today's lesson. Covalent bonds are bonds that are formed between two or more nonmetals. Okay, so we're looking at now the right of the aluminum staircase. Now, metals are not involved at all with a covalent bond. Okay, nonmetals in a covalent bond share their electrons until they achieve that stable octet. Okay, or they pretty much achieve the octet rule. Identify whether the following compounds are ionic, polyatomic, or covalent. So far, up until now, we have looked at binary ionic, we've looked at polyatomic compounds, transition metals. Okay, so we're pretty much looking at the very first premise when it came time to name compounds, and that was to identify metal or non-metal. So let's look at the first compound here, AlBr3. First thing you want to do is identify metal, non-metal first, and we happen to have that. Aluminum is the metal, bromine is the non-metal. Okay, so therefore we have an ionic compound. Let's look at the next one, NaNO3. Identify again, metal, non-metal. Na is a metal, NO3 is a non-metal. And if we notice this non-metal, it's nitrate. So therefore, okay, two non-metals mean that the two non-metals represent a polyatomic compound. Next example, CO2. So the first and foremost step was to identify metal, non-metal. But when you do try to identify metal, non-metal, you'll notice that, well, O2 is a non-metal, but so is carbon. So here we have two non-metals. There is no metal, so therefore we have a covalent bond that is formed, and we have pretty much a covalent compound. And the next example here, we have CH4. Again, identify metal, non-metal first. And well, we have a non-metal, and we're going to treat the hydrogen also as a non-metal. So if a non-metal appears first, it's covalent, and the non-metal here is carbon. And then even though hydrogen, we find it over on the metal side, we don't treat hydrogen as a metal. Okay, we will be treating it as if it's a non-metal in bonds. So hydrogen always bonds as a covalent bond with non-metals, even though it's on the side of the metals. Now, when naming covalent bonds, we use prefixes to show the number of each type of atom in the formula. So here are the prefixes. 1 for mono, 2 for di, 3 for tri, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10. Now, here's an important note. If there is only one of the first elements, the prefix mono is omitted. So we're not going to use mono with this, mono that, as you'll probably come across the occasional time that we'll use it. We're not really going to use it. But for you to know, if you do see it, you do use mono at some occasions, and we'll see that as some of the worksheets I'll be handing out. So let's look at the first one, CF4. Remember that the second element has an IDE ending. So in other words, this should be some kind of a carbon fluoride. Remember that the second of the two nonmetals has the IDE ending. Okay, but we have to keep in mind, we have to list all the elements. Well, we have here, so when we're going to do the steps for CF4, we're going to identify metal, non-metal. Both are non-metal. We're going to write out the element names, so we know we have carbon and we have fluoride. Remember, IDE ending, okay, an IDE ending for the second element in the compound. Now, how many of each one do we have? So count how many of each element we have. Well, how many carbons do we have? Well, we have 1 carbon and we have 4 fluoride. So how do we put it together? Well, according to the prefixes, okay, we want to use the prefixes at the beginning. Okay, obviously prefix at the beginning to represent how many of each one. So normally we would say for one, we know it's mono, but we're not going to write mono. We're just going to keep it as carbon. And notice we have four, okay, we have four fluorides. So the prefix for 4 is tetra, and we put it at the beginning. So there's 4 fluorides, so it's tetrafluoride. So the name of this compound is carbon tetrafluoride. N2F2. Now, normally in the ionic compounds, we would be simplifying something as follows: N2F2. But in covalent compounds, okay, let me write it in red. There's no simplifying. Okay, there is no simplifying. So we keep it as N2F2. Remember, no simplifying covalence. So, let's go through the steps. Identify metal, non-metal. And of course, before you did that, before we know that we can't simplify, we'd have to be able to identify that they're both non-metal. We're going to write out the element names. First one is nitrogen, the second one is fluoride. Remember, IDE ending for the second element. Okay, how many of each one? So we're going to count them. We have 2 nitrogen. Okay, 2 nitrogen, and we have 2 fluoride. So think about the names now that are used for those compounds. We have, according to the prefixes, the 2 nitrogen, 2 fluoride are represented as dinitrogen difluoride. PCl5. So let's go through the steps. First thing, we're going to identify metal, non-metal. And we don't have a metal and non-metal. We have both our non-metals. We're going to write out the element names. P is phosphorus, Cl is chloride. So phosphorus chloride. Okay, how many of each one do we have? We have 1 phosphorus, we have 5 chloride. So using the prefixes, because phosphorus is already just a 1, we just keep phosphorus. And instead of 5 chloride, we use the word pentachloride. Now examples, N2O5, N2O4. Here are a couple of examples that you might come across. Notice the bottom one, N2O4. Normally we would simplify it, but because we said covalence, you do not simplify. Okay, because they're both non-metals. So, we have here what we call dinitrogen pentaoxide, dinitrogen tetroxide. But be careful with naming these, okay, especially when using penta or tetra in front of oxide. One thing to keep in mind that when using the prefix tetra and penta in front of oxide, drop the letter A from the prefix. So we're no longer using those A's. So the name is no longer dinitrogen pentaoxide or dinitrogen tetroxide. It's dinitrogen pentoxide without the A and dinitrogen tetroxide without the A. So, few practice questions. At this moment, I suggest that you pause the podcast and try to complete the following questions on your own. Welcome back from completing the practice questions. Let's take up the following practice questions. We have SO3, we have 1 sulfur, 3 oxygen. We've identified that all of these are both non-metals. Okay, so we are going to be using the prefix rule. So we have 1 sulfur, so sulfur, how many oxygen? We have 3 oxide or 3 oxygen. So the name is sulfur trioxide. Next one, we have a carbon and 2 sulfur, so we have a carbon disulfide. Notice we have 2 sulfides, 2 sulfides. So P2O5 is called a diphosphorus pentoxide. Notice in this example here, we have 2 phosphorus and we have 5 oxygen, okay, in our example. Next one we know is water, but using our prefixes rule, we're going to call it a dihydrogen, 2 hydrogen, and the 1 oxide. So dihydrogen oxide, or if we wanted to, we could fit in the word monoxide. Okay, so a dihydrogen monoxide. And lastly, PBr3 is a phosphorus tribromide. Okay, notice there's only 1 phosphorus, so we just have the name, and we have 3 bromide, a tribromide. Now, let's do the reverse of what we've just done. Writing formulas of a covalent bonds. Carbon dioxide. So, let's look at the steps. Again, identify metal, non-metal. And we know that they're both non-metal. Here's a hint. Okay, here's the hint for the non-metals. How do we know that we have both are non-metals? If you see the prefix. Okay, so prefixes mean both are non-metals. Okay, so next step, we're going to write the chemical symbols. So carbon is represented with the letter C. Oxide is represented with the letter O. So we have carbon, we have oxygen, but according to our prefixes, there is 1 carbon and 2 oxygen. Okay, and the formula is CO2. So look at another example. Dinitrogen tetrafluoride. Again, we know we've identified metal, non-metal, and we know that they are both non-metals. So we're going to write out the chemical symbols. Dinitrogen, we write down the N. Tetrafluoride, we write out the formula F. How many nitrogen? Well, we have 2. Okay, 2 nitrogen, and we have 4 fluoride. Okay, and remember, covalents do not simplify. Otherwise, if I simplify N2F4, it no longer will be called dinitrogen tetrafluoride. It will be called something else based on the new subscripts. Okay, and let's wrap it up with the following practice questions. Here's a great moment now to pause the podcast and try to complete these on your own. Welcome back. Okay, so hopefully you've completed the following 4 practice questions. Let's take up the 4 questions. Dicarbon tetrahydride. We have 2 carbons and we have tetrahydride, 4 hydrogens. So the formula is C2H4. Triphosphorus decabromide. We have triphosphorus, meaning 3 phosphorus. We have a decabromide, meaning 10 bromides. So the formula put together, P3Br10. Silicon dioxide. Okay, we have 1 silicon, so Si. We have a dioxide, 2 oxygen, SiO2. And finally, carbon tetrachloride. We have 1 carbon. We have a tetrachloride, meaning 4 chloride.